Okay, welcome everybody. Tonight is the 20th of September, 2022. This is Dallas Personal Robotics Week, Robot Builders Night Virtual. We'll just gather around the table and go around and talk robot-y related things like usual. Housekeeping, I don't think has changed at all in the recent past. As we can see here, our next big event I'm aware of is in the middle of November, Robo Columbus. Hopefully we'll have a couple of competitors ready to chase those orange cones. And then we had a handful of ideas on the backlog as potential wish list items. Are there any other things come to mind we should add to this list?
Well, I don't know if I think it kind of be on this list is John came up with another Raspberry Pi hack that he's put out there, and he said we could put it on the website. And so if I'm speaking wrong, John, tell me. So I didn't get a chance to look at it this week, but I since it looks like my robot's going to end up with a Raspberry Pi on it, I can definitely use his hack. So, yeah. So, John, one question: you only had two buttons on your board.
Well, I had two buttons and two switches, momentary contact buttons, and then two switches for settings to enable them.
Okay, so you have four actuators or whatever you want to call them. Okay,
Yeah,
I was curious.
Yeah, the switches are really intended for configuration because they're really tiny and you got to get in there and it basically just flip them one time and leave them alone for the most part.
Yeah. Okay, what I'm saying is, when you went to Osh Park, did they give you like 5 boards or did you end up with just one?
Their minimum order is 3 boards. As a matter of fact, if you need one, I might have one left over.
Well, if you do have one left over, I would definitely be interested.
I will check right now.
Okay. Can you also show me what switch it is? I think I got those push buttons, I'm pretty sure. But switches the footprint might be weird. So, I mean, I don't know. I might have to look around. Did you, is it in your GitHub? Is there
I don't have a bill of materials in there, but the layout is in there. The PCB layout.
Yeah. Okay. I just haven't had a chance. This week's been a little hectic for me.
Wait a minute. I'm sorry. I might not have uploaded the PCB layout included. Anyway, I'll look into that.
Did you do it in KiCad or did you do it in Eagle?
I did it in KiCad. What do you use?
No, I like KiCad. I call it KiCad, but I like it. I like that a lot better than Eagle because there's something, all the Autodesk something a little weird about them that I just can't seem to wrap my mind around. I'm not saying they're bad because they're obviously good. Like Fusion 360 and everything. There's always something about the interface that I find personally distressing.
Yeah. Well, let me check for that board right now.
Okay.
While y'all queue up.
Okay. While you're checking on that, we have this in queue so far. We have Ray, then Michael, then Harold, then Doug. Anyone else want to add on queue before we dive in? Okay. And John G, should we hold for a moment or do you need a few minutes? That was an arm wave to...
I say y'all go ahead. If I don't find it in this box within the next 2 minutes, I don't have it.
Okay, good. So we'll go Ray, Michael, Harold, Doug P, then John G. So Ray, what do you got?
Okay, just a short video. Hopefully it'll all work. That's weird. We did the
You're not moving, Ray. Oh, there you
I
go.
lost connection. Can you hear me?
We can hear you.
Oh no. Oh, you can't hear me?
We can.
Well, you can.
But there you go. You're moving. You're like freezing, moving, and then you freeze again.
Yeah. Internet connection, I think.
John, what are you building?
What am I building?
Yeah, sounds like you're rummaging through a bunch of parts.
Oh, I'm sorry. I meant to mute while I was rummaging through my spare PCB box. But there it is, Doug.
Okay,
I got my spare.
great. Like I say,
I put some parts on it for you and get it to you.
oh, that'd be even better. Tell me how much you want for it, and I'll send you. Do you do PayPal, John? That's the easiest way to make sure you get it.
Oh, don't worry about it. I'll do it for free.
Oh, well, it's even better. I like that, John.
You just do me you just put it on the list, and sometime in the future, you can do me a favor.
Okay, gotcha. I see something. Is this right here? Yeah. I see a boot. Oh.
I see a lawnmower that's about to mow down a cone.
Ray, is this robot dragging butt, or has it got some sort of caster?
And Ray, you're on mute, so if there's any soundtrack you're trying to convey, we got it through sign language. You're still muted, Ray.
Ray, mute.
No.
Ray, unmute.
Can you unmute him, Carl?
Nope. Violates Google's privacy things.
Oh, I got you. I think he's going to tell us that it drove to the cone. I see a GPS on it.
Yeah. Maybe his audio is not working either. Maybe if we text him in the chat. Or maybe if we grab his attention with a audio is muted.
He just
Ray, read your chat down wherever side that is. Ray, read your chat.
Well, he's presenting, so he can't see anything.
He's not looking. Okay.
Yeah, when you present, you can't see what's on the, I mean.
Yeah, most likely. But we can imagine what he's saying.
Yeah. And here it goes. Oh,
Well, that was okay. Anyway,
Oh, there you
what
go.
that showed.
Yeah,
won't
what
put you
what
through.
happened
For some
there?
reason, I muted.
Yeah.
The robot was using GPS to find a coordinate near the cone, found it, stopped, scanned with the color sensor, and then the cone and tried to run into it so it could bump it with the bumper. And after it bumped it, it backed up like 50 centimeters, half a meter or so. And,
Cool. That's real progress.
Yep. So that's working good. I found this was killing me. I didn't account for zero angle of rotation. And I thought, oh well, for just some reason, I thought it would always be positive or always negative, but not zero. And finally, it's like, oh no, it could be zero.
Yeah.
Anyway, so got that working. So it should go to all three cones and find the GPS, use the GPS coordinates to find the cones, and then use the color sensor to locate the cone and drive to it and bump it.
Okay.
I was kind of curious what he's doing with, like if I approach the cone and the angle to the next cone is, or if that cone that I just bumped is in the way, are you guys, is there people using obstacle avoidance to get cone?
Well, I think the cheap way, the one that has is to back away far enough.
Yeah, but how do you know
Yeah.
which angle to back away?
Well, you know where the next cone is, so you should have a heading. You
Okay.
can know the heading before you back away.
Oh, all right. Okay.
And so you might want
So
to
you
do
can
a back
clear it.
away, and then turn before
Yeah.
you actually start to head towards the cone.
Okay. Yeah.
I mean, I'm sure there's better ways, but I'm just saying,
Yeah.
you're lucky in the sense that you're using a differential robot, so you can turn almost in the spot.
Right.
Like in my case, where I'm using Ackerman, I really need to move to get away from the cone.
Yep.
Ray, I just back up. It's just a period of time at a given speed, and then I
Okay.
stop and I just rotate to the heading, wherever,
Yeah.
which would be the next cone at that point, or wherever you're heading.
Yep. Okay.
That's basically what you were saying.
Yeah.
Yeah.
Now, another thing, Ray, you could do is turn your cone searching routine off
Mm-hmm.
so it doesn't see it
Yeah.
until you start moving till you reduce the distance, or until you get a certain distance from your previous log point or whatever.
Yeah.
Well, I use the distance to the next coordinate.
Yeah.
So I have to be, I think it's like 40 or 50 feet within the next cone. Because if you look at the contest rules, the cones are going to be at least 100 yards apart, right?
Yeah.
So-
Well, I think it's 80 to 120 or
Well,
something.
it's a lot less than 40 feet.
Yes.
So I have to be within a
Lot
40
more.
feet radius of where I think the cone is to even say, I'm going to start looking for a cone. So that way you can leave the cone you're at, because it's at from where your destination, where the next cone is.
Okay.
That's how I handle it anyway.
Yeah. Anyway, the other question I had is, does anybody have one of these? Oops, let's see if I can get a B6 Mini or one of the clones.
I've got one of those, yeah.
You do?
I've
Have you had
Yeah.
got one of the full size ones.
Yeah.
Oh, okay. The one that you plug in an AC cord into, not
Yeah.
DC voltage.
Yeah.
Yeah, that's what I have too. I have one you plug AC into it.
Oh, okay. Anyway, had it for a couple years. I don't know how many times I charged batteries with it, but it crapped out today. I was really disappointed. Looks like it starts to set up the the battery charging for like a balanced charge and doesn't do anything. So I wondered if anybody else had an experience with similar.
Well, I know that there's so many clones of that.
Yeah.
And I've read people are saying, well, I got this thing, it's a piece of crap. And then you read somebody else who says, it's slicker than, sliced bread. But so, I bought mine from Hobby King, I believe,
Oh, okay.
and I bought it from a reputable dealer as opposed to Amazon, where they got so much crap on Amazon now that's really truly crap.
Yeah.
It's amazing how bad some of the stuff on Amazon has gotten.
Hmm. Yeah, this is, I think Sky RC was the company that made
Yeah.
made these, and this one does not say Sky RC on it, so it's
Yeah.
obviously not from them.
Mine says it's a Thunder AC6.
Okay.
Could it be something as obvious as a busted wire or open
Yeah.
unit on a balanced cable?
No, well, there could be. It's kind of tight. I'd have to really tear into it. There's a excuse me, there's an LCD in it, like a 2x16, I think, and it's soldered on both ends, soldered into the board, and I don't know how many pins that connector had on it. Maybe, I don't know, less than 20, but probably close to 20. So I'd have to bend that out of the way or desolder it to get to the internals of it. Anyway, yeah, I haven't given it up on it yet.
Yeah, I guess what I would consider doing is putting it into, like a load resistor and measuring the voltage and see if you're getting an output at all. Just see what you get.
Yeah, I've got. It
You're
looks
saying-
like
Go ahead.
when I hook it up to a, and have the battery plugged in, and when you're on this one, it's probably similar. You're supposed to hold the enter or start button for 3 seconds, and then it starts to charge. And the current on the power supply jumps up just a little bit and then jumps back down to, I think, like 50 milliamps. It goes up to.
What is the
maybe
voltage that it's saying it's supplying?
I tried it for several different things. Like it's got, I think it has to have a step up converter because, even I think the nominal voltage is, you're supposed to hook it up to like a 12-volt battery. So I think they say between 11 and 18 volts is what you can put in it. It says, yeah, right there on the edge.
Yeah.
Probably pretty hard to read.
Mm-hmm, mm-hmm.
But so I tried it at 12. I tried it, at 17 because I have a 4-cell battery, and to fully charge it, it's 16.8 volts. So I thought, okay, maybe the DC to DC converter inside the thing is shot or something, but didn't seem to help. Doesn't do anything.
Yeah. Well, on mine, okay, you select. First of all, you got to select LiPo balance, and then your number of cells and the charging current that
Right.
you want to do. So you got to make sure you've got some number in the charging current.
Yeah.
I usually use 1.2 amps because I usually have more time than have to worry about it.
Yep.
And then you hit go, like you say, you hit the activate button for 3 seconds, and then it comes up and does a little test on the battery, and it says 2-cell or 3-cell, and it says, yeah, we're good. And then you push OK again, and it starts charging. And on that charging, it has the current that it's supplying and the voltage that it's supplying displayed, and then it accumulates charge. That's the number that keeps going up.
Yep.
And so
yeah, this is similar.
Yeah.
It tells you what each battery voltage is, and or how many batteries, or how many batteries you got, all that.
Yeah, I guess some first thoughts are, you sure you're on LiPo and not?
Yeah.
There's a couple of LiPo options.
Yep.
Which have different voltages per cell.
Yep.
And there's some weird things like that. Is your battery below 3 volts per cell?
No, it was more like, I don't know, 3.66 per cell or so.
All right. So it's not a dead battery.
No.
Oh, you're not getting any current. It sounds bad.
Yeah, I know. It's kind of like, oh.
I tell you what, I had to pay, I think, an extra $10 or $15 to get the AC version. And I never looked back.
Yeah, I think I know.
Nowadays, they, I think I think you call it AC6 because you can go up, depending on how many cells, up to 6 amps. And I could say, so it's kind of on the small side compared to what today's chargers are. Now they have chargers that will charge much higher, they have much higher watt ratings than mine.
Oh,
But,
okay.
but mine has never bothered me. And I have to read through the manual every freaking time I use it.
Yeah, it's not real
Yeah.
obvious,
Yeah.
if you don't
Especially-
haven't used it in a while.
Yeah, especially if you're doing lots of weird batteries, like if I'm doing a Vex battery or something like that, where I have to change it all completely all around, then to get
Yeah.
back to the right spot is tough. And you can do it balanced or you can do it unbalanced. There's just too many, but it works.
Yeah.
And like I say, if I were buying it again, I would continue to buy one that had AC power because I think it also has a DC power. No, I guess not. I was going to say, I thought it had an option to let you do DC power too, but on that line, it's just AC.
Ah,
But I think some of them are dual.
yep.
Yeah.
So which
So that means
ones?
you'd have it in a switch in the wrong position all the time. But other than that,
Yeah,
see,
So-
that way you don't have to worry about a 12-volt supply or anything.
yep.
Yeah, mine appears to be a dual, and there's no switch that I can see.
Yeah. Oh, that's good. So
Huh.
so you can put in DC power or AC.
Yep.
Yeah.
Yeah, that's the real version. Well, that's another version, I guess. The IMAX is, I think. Oh, well, there it is. Sky RC right on the top. Yeah.
Which means it might be a clone or it might be a real thing. Who knows?
Hard to say. Yeah.
It might be a real thing. That was one of the criteria that I had for when I bought it, was
Yeah.
that it had that
Yeah.
on.
Yeah. I know I didn't buy the cheapest one, Ray. I
Yep.
ended up, one, I read all the reviews. And like I said, I think I got mine. I'm pretty sure I got it from Hobby King.
Okay. Yeah, I didn't want to have to mess with it. I just wanted to use it. It's like, ugh.
Yeah, mine is a B6 AC version.
Version 2. Yeah.
Yeah.
V2. Yep. Yeah, that's what you get for buying cheap.
Yeah.
Yeah, I know one of the things that that you can do is you can just go through and check all the capacitors, because electrolytic capacitors are pretty notorious for failing, and they may have used subgrade components. Who knows? Maybe one of them shorted out or something. But the other
Well,
stuff, really going to have to hack into it.
The other thing too is, you might have said it was good for 18 volts, but it's really good for 14 volts, and you put 17 volts in it, and that was the end of it.
So that was
Yeah.
it. Yeah.
Yeah, I mean, it
Well,
could be
It
You
even
know.
tells you if you're over voltage or under voltage.
okay.
So if you go up to that, either limit, and it'll, a little message will appear and
Okay.
tell you you're at a range. So,
Cool.
but yeah, who knows? Maybe, like you said, maybe it was really intended for 14 volts, and
But I would definitely go with AC. Here's why I do that. If I had, in my case, I have a couple of small 1,000-watt inverters that hang around. I just put them into the car socket if I have to use the 12, if I have to use 12 volts, because
Yeah.
I'm not going to have 12 volts any other way. I'm not
yeah,
carrying a car battery around with me like some of the RC people do.
right. Or, a bench supply or something.
Yeah.
But
Yeah,
that
yeah.
requires AC.
And you can use your bench supply.
Yeah,
You can't balance it very well, but you can use your bench supply.
Yeah, I actually made a little converter cable to plug into the bench supply into the battery, and it worked fine.
Yeah.
And I slowly crank up the voltage to keep the current around 1 amp or so.
Mhm.
I could probably charge, well, I think that one, you can charge up to the capacity rate. So I think I could go up to 4.5
Yeah.
amps, but
Well, I think the thing you want to do is you want to figure 4.2 volts per cell,
mhm,
and you can't exceed that value.
yeah,
So you put it up to 4.2 per cell. So if you have
yeah,
8.4 for a 2 cell, or I guess whatever, 12.6 for the 3 cell,
right.
and you turn your
16
current
amps.
up, you turn your current up to what you want it to do, and then you let the
Mhm,
current just go to 0.
right. Yep. Yeah, I don't know if it would go over the charge rate. It could. I just limited it to an amp, and I was sitting here
Mhm.
tweak it up every time
The
the
thing
current
is
goes up.
if you go to take the battery above 4.2 volts per cell, you will destroy it.
Oh, yeah.
And it can be a catastrophic destroy.
Ooh,
So you have to be careful about that.
yep.
That's all.
Yeah,
That's,
like Doug says, it's a current and a voltage limiting thing that you need.
Right.
And so you need a power supply that you can set both of them.
Yep. Yeah, it's a min leaf 30 volt 10 amp, and it's more than adequate for that. So,
Mhm.
and you could put it in constant voltage or constant current mode. But
Well, most of those that are constant voltage or constant current, you can actually set both of them as limits.
Yeah, you have a current limit on the voltage, and I think it would be constant voltage is what you want.
Mhm.
Set it at the max max voltage, and then, like I say, it'll take whatever current your supply can do, and
Right.
then it'll just drop it down to 0. And when it's down to 0, you're good.
Yeah.
You don't have to worry about changing things in between.
Yeah. Yeah.
And
Yeah. I
usually,
didn't do that this time, but
and what I always do is I always check the voltage with no load. That's
mhm,
how I set the constant voltage, and
Yep.
that way I make sure it's right.
mhm.
So I'm guessing none of you guys use thermistors on the battery pack.
Actually,
that-
it's got a temperature sensor
Yeah.
right there. Boop.
Yeah, I mean,
Yeah.
that's my understanding of how it's done in laptops and phones, just for safety.
Yeah.
Because
Yep.
voltage and current aren't enough. It's also temperature.
mhm.
Right. Yeah.
and smoke, I guess.
And
Yeah.
so
I think that's
want to keep them
Carl.
all in
That's
balance.
that's also when they're really, really, really deeply discharged. That's when because now your current's going to be the max. You know what I mean? You're
Mhm.
really pushing the current, and
If you
then
allow-
they throttle it back a little bit.
Yeah.
Yeah, just hooking it up to the power supply and not. Yeah, I checked the cell voltages, and they were within a few millivolts of each other. So
Yeah.
it's
mean-
As long as they stay that way.
yeah.
You don't
So,
want one to go dead or shorted, and the power supply to try and raise the voltage of the whole pack and take one of the cells way over for
Oh yeah,
the
yeah.
upper limit, because that's
Or all of them way over.
yeah, to compensate for the bad one. So that's why I wouldn't touch a charger without a balancing on LiPo,
Mhm.
at least unsupervised, because it's just too dangerous.
Yeah.
Yeah.
And one of these chargers is good. I haven't had any problems with mine, and I think Dave said the same thing, and I'm sure Scott hasn't had any issue. So I mean, they do. I think Carl has one too, don't you, Carl?
Not the Sky. I use Triton Electrofly.
Okay, yeah, but it looks the same, right?
Yeah, it's the same concept: multi-chemistry, multi-cell, all kinds of knobs and switches. But it does change the voltage threshold for chemistry. So when you say it's LiPo or LiFe or a lead acid, that selects the algorithm and the terminal voltages.
Yeah, same with mine. That's what I'm saying though. if you don't want to get it on the wrong battery. That's what they do, it's possible to get everything on the wrong battery. So you just have to be really careful when you do set it up.
Yeah, on all the multis. Yeah. Actually, I have two of them. I have a really old one and a pretty current one. I don't know how current. It's now years old, but
I don't know. Yeah, I haven't had any trouble with mine. And, like you were saying, you hold the button for a while, like 3 seconds, I think it is. And then you have to confirm. And that's when it's checking the voltage range of the battery. And like Doug was saying, if it's too drained, then you got to put some voltage in it. And usually when that happens to me, like I've left the switch on or something, and the thing's completely dead, I just trickle charge it on my bench top and then stick it on the balanced charger. But no, I haven't had any trouble out of it. But I agree with Doug too that, man, go AC and just be done with it.
Yeah, I think you're right.
It's not worth it.
Yep.
I don't know that the dual one, I don't remember if it's more expensive or not. I think that's the one mine is. I don't know that that's worth it. Just go AC and be done with it if that's a cheaper option.
Mm-hmm.
All right. I think it's still true. You get what you pay for.
Yeah.
Ray, gold star.
Yeah.
Nicely done.
Yes. I got to write this down so I get it all.
Yep. I put it in the chat there. Do you have more, Ray?
Nope, that's it.
All right. Well done. Let's see. Is Michael still online? I don't see him.
I'm still here.
You're still there? Okay. Your video. Are you good to go?
Yeah, dude. I want to present this this arm.
Cool. All right. So we got
Entire screen, I guess. What do I present here? Window.
Screen. I think is
Entire
the
screen.
easier. If your machine's fast enough to screen scrape.
Let me see here.
There you go.
What? Screen. Oh, here's entire screen. There we go.
Seems to be.
All right, y'all get the screen.
It's presenting. Although you're presenting the screen,
Hold on.
presenting the screen.
Hold on. Is that it?
Yeah, it looks small though.
Yeah, you
Well,
need to.
Let me redo this.
That seems to work right there.
That's working. Okay, that's just me presenting. You see that?
Yeah.
All right, so I told y'all here a few weeks ago I was starting a new claw machine. The arm, this is just, this is definitely in the test bed here. So it's going to be a little bit bigger, but I'll try to explain to you the concept. But right here, what I wanted to do is I want to feel, just like any kind of claw machine at a carnival or something, or an arcade. I want to feel the prize bed here, and this will turn, and this will have a motor on it. It'll turn 180 degrees. It'll be in the back of the box. But what I wanted to do was at this point here, you can see my scale right there. I wanted to keep this point, the end of the robot, relatively at the same height as I extended the arm out. So I'm using two servos to do that. And you see how it's pretty much the same height as it gets out. And the reason why I want to do that is these two nuts here are going to simulate my claw. There's going to be a claw on the end of it, right? Like there's a claw right there. But the reason why is that when I get, of course, this is going to be taller and a little bit bigger, is that when I get to the point, when the kids get to the point to where they want to drop it, they'll just push a button and this will drop down and this will stay the same height. and then the claw will grab the item, come on back up, and then go to drop it in the dispenser. So my challenge for me was I programmed this in Arduino without a breakout board or anything. I'm just using the Arduino servo code. So I had a challenge to program these servos to keep this height pretty much the same, and I did it. So I'm kind of proud of myself on that. I got a question for you guys though, but that's pretty much what I got. It's in rough form. I got these counterweights, the spring and rubber bands right now for a counterweight on that, keep the load off that servo so much. But anyway, that's what I got.
Oh, I see what you're talking about.
Oh, you do?
You
Yeah,
just
it
moved
stays the
it,
same height.
extend it, and
So
everybody
when
watch the end of it. It all stays at the same height.
same height.
Yep, cool.
See, now I dropped these nuts, like I said, represent the claw.
Yeah.
It'll drop the claw and pick up the item, and then go and dispense the item into the dispenser, and it stays the same height. So that was a challenge for me, and it's a good accomplishment on my skills. I mean, as far as I'm learning my programming skills on this stuff. I got a question for you guys. How many servos how many servos can you control at one time with the Arduino itself without having to go to like a shield or breakout board? Without having to go to a servo driver board?
I want to say 12.
You can do 12 servos
I think so.
just by the Arduino?
Yeah, well, you can't power them off the Arduino.
No, I'm not saying, but just to control them.
Yeah, I believe I've seen.
Wow.
If you look at the servo library, I want to say if you look at it, I think some high number, 8, but I want to say I've seen examples of 12.
Wow. Okay.
Yeah, but the easy way to is something I'm going to show a little later as part of my robot, but you might consider it's Adafruit or Adafruit clone of their 16 servo breakout.
Yeah, I've seen those.
Yeah, I mean, if you get the clones, they're only a few. Well, I'm sure they're more than $3, so they're probably about $10 now. But it's still, it only uses the I2C bus, and that makes it pretty nice.
Yeah,
It's a very nice package.
Yeah, I'm using one of those 16-channel Adafruit servos in my Halloween project.
Yeah.
Yeah, Polulu also made the Maestro, I think, or Maestro series.
Yeah, I've got a couple of those.
Yeah.
Yeah. It turns out that the Maestros are not necessarily compatible between themselves. Otherwise, you can't like program for an 8-channel and then all of a sudden move to their 16-channel. Something changes that doesn't work. You have to you can program it, but you have to let it know which servo board you're using. They're all a little different.
A word of caution about those Adafruit 16-channel servo drivers. I have toasted a couple of them. It turns out that if you have power applied to the board, and then you actually connect the servo at the moment that the power's on, it can fry the board. I've done that to 2 boards.
Say that again.
Wow.
Say that again, John, so I understand.
If you have power applied to the 16-channel servo board,
Using the 2-pin.
yes.
Okay.
If your servo power, not your logic power, if your servo power is on, and you plug in a servo into one of the 16 channels, you can fry the board. I don't know what makes that a vulnerability, but I've done 2 of them like that.
So
Yeah, he's got a gold star. Mike's got one. He showed it move.
Yep. I wasn't using a hand crank or nothing. It was electricity.
Real electricity.
Police.
Smoke and mirrors.
Now, let me ask you this, Mike. Is that mainly 3D printed right now?
That was all 3D printed, yeah.
Okay, I saw some different colors. I was a little, I wondered if you were
Yeah.
using Lexan or anything.
No, I'm using 3D printers. No, I got two 3D printers. I've got I've got a 10, one of the big Ender 10. So, and then I've got the regular Ender. But I get a kick out of drawing this stuff. I like it better. Well, I don't know. I like it all. But anyway, I got a question. So, as far as using driver boards for your servos, the benefit is to use less pins.
That's
Arduino or whatever.
John can probably answer some of this, but the way I would say it is, yes, you use less pins, and it's a very neat package, very easy. Otherwise, all your servo just plug right into it, and if you do it straight off the Arduino, somewhere you're going to have to create that interface. Okay.
In the
Somewhere you got to have, no, on a board, somewhere you got to have a ground pin, a power pin, and a signal pin. And that's all on these little driver boards. And,
Absolutely.
And that's definitely a big advantage.
Right. And it's more than an advantage. I would say that it's virtually a good design requirement to keep your power, your motor power, your servo power separate from your logic power.
Right. Yes.
Yeah, I do have that. I'm powering this right here with a bench power supply, so I do have that separated.
Mm-hmm.
So, okay, that's cool. That's good. So, but as far as logic is concerned, and the Arduino is fully capable of controlling all of them.
Providing signals, not power.
Yes, that's what I'm talking about. But they have the ability to control providing signal to multiple servos at one time.
Okay,
Yes.
I just looked up on the web. It says, can Arduino control servos? How many servos can an Arduino control? Here it says that a Arduino Duo can control up to 60 servos.
Yeah, but that's not a Uno.
No, I'm saying it's a Duo. The one with the more pins.
Yeah.
But it's,
But
That's
like
pretty
I said,
good.
and if you use these little interface boards, you can use 2 pins, and you can, I think, put 4 of them end to end, 4 or 5. I can't remember how many addresses you can change. I think it has a range of 5, so it would mean you could put 5. So that'd be 16 times 5. You could do that. No, I wouldn't do it, but I'm saying you could.
Right. I was just curious because I'll probably go to one of those driver boards. I'm just trying to get the concept of what I want to do.
Mm-hmm.
And
The other advantage of the driver boards is that the CPU horsepower and the accuracy of the timing, because the interface boards have a timer chip on them, and you basically just write to the timer register and tell it, where to position the servo. Versus trying to bit bang it in software. And then you're doing, once you get 5, 6, 8, 10, 16 servos, and you're trying to bit bang these with IO off of the Arduino, you can't do a lot more other than that, is what I'm driving at. And any kind of interruption in that timing, then your servos flicker and jitter. I mean, I have the same problem with CanMan, because I just bit bang those, and it's just 2 servos. But every now and then, it just gets a little off, and they'll twitter or twitch.
this one will do that. This one will start shuddering.
Yeah, and that's because your timing signal to the servo isn't accurate. It's not consistent, right? So it's just trying to follow what you're telling it to do. Whereas these carrier boards, you just write to the timer register, and I think you actually write to it 8 bits at a time, right? Or to each channel. I forget how the interface works. I think it's I²C.
It's I²C. At least the ones we're using from Adafruit are I²C.
But it's a lot easier way in software too, because you can also update the servo and forget about it, right? Until you want to move it again, you just update the register for that servo, and your software goes and does whatever it wants to, and then it can manage, a lot more servos a lot easier that way. And the software, I think, ultimately would be a lot simpler doing it that way as well.
Yeah, it's, if you can manage to do a good I²C wiring job, it's definitely advantageous to do the little, and they're not expensive. They're not that expensive. And I want to say, if you look at how it divides the signal, one of them, I think the Arduino is 10 bits or maybe 12, I can't remember. And those chips are using 16. So, or whatever 496 steps is. It's
12.
12. Is that 12?
Yeah.
Okay.
Yeah.
Okay. So they're using, must be Arduino uses 10 and they use 12. So it's even more accurate, so.
Yeah. I wondered about that. Can you get like sub-degree, position accuracy though, or is it still just whole degrees?
Somebody said micro. What was it I was reading? I'm using degrees on mine.
The one I just pasted on Amazon claims the 12-bit resolution gives a 4 microsecond resolution and update rate of 60 hertz.
Yeah.
Right.
So whatever a 4 microsecond translates to in servo degrees.
Pulse width. Yeah.
It can do floating numbers. The microseconds can do floats to where when you use the angle, that's what I think I read on the Arduino site. And that when you just do integers, it's not as accurate. But I'm doing integers with mine.
Yeah.
So,
but
is that what you're kind of saying, Carl?
So what?
Is that what you were saying? Is what you're reading?
Well, the link I put in there is, I think one of the common driver boards uses this PCA 9685 chip.
Yeah.
With I²C interface, and and it says 4 microsecond resolution with a 60 hertz pulse rate.
Yeah, the 16 channel Adafruit board uses a PCA 9685.
Yeah, I think it's a really common, but I think what everybody said sounds right to me, that it's fire and forget. You just write to it. So as long as you remember to put the default value in if you need to, and you don't lose your I²C.
Yeah.
But otherwise, you try to drive this with the software servo library or the hardware timer on the Arduino. You're still depending on interrupts on that Arduino to wake up and fire the servo signal the right time, and it'll have some jitter. And I don't know if these PCA 9685s, do they have hardware timers in each one, or are they just little microcontrollers? I don't know.
No, it's actually a LED controller. So basically, it was originally designed to PWM LEDs, like multicolor LEDs, or RGB LEDs to create, different hues. So, but someone, I guess, figured out, hey, I can slow this thing down from where it's really designed to work and run a servo from it. So yeah, you can set the period, you can set the duty cycle on them. It's really not that hard to set up, and
yeah, you can do the range, maximum. So like if you got a servo that's not quite 180 degrees.
The other thing about, you were saying it was 4 microseconds of resolution, Carl, but don't don't confuse resolution for accuracy, right? Because I
Right.
think on the
right.
servo itself, you only have, a finite number of spots, right? I mean, it's really, I mean, that's what they're digital servos, right? So they're only going to have a certain, resolution as far as the rotation
Right.
goes.
Right.
But you're splitting hairs though. How thick is the hair, um, and how accurate do you really need to be with a servo? That's
And Mike, that's another point that Scott alluded to, is you can have two types of servos. You can have an analog servo, which is the old style, which if you bought like what is it called, an MG996, which is a real common one, I believe that those are analog. But you can also get digital servos, which will do better at driving to exactly where you want it to be and not jittering. So if you've got something that you absolutely have to be still, you might want to buy a digital servo. You'd have to check. I don't know. I'd have to look up. Maybe the 996 is a digital servo, but I think it's an analog.
They're all going to use the analog potentiometer for feedback, right? None of the servos we're talking about are going to use a high res optocode or something. So really, sure.
The digital servos are definitely better.
Well, I've understood that they have like a more tighter control loop.
I thought it was how the sampling rate of the input pulse versus the control of the location of the servo. I think that's where the distinction comes, because in the digital servos, they basically have a whatever, whereas the old ones, generated an analog reference that was compared against the pot. But yeah, you're right, Carl. As far as the position, I mean, yeah, they're all potentiometers, which is why I'm saying that you can probably control it closer electronically than it can mechanically or as a unit really be controlled.
Gear slop and all that other stuff.
Yeah.
But I think you're right. If the digital ones, so I think back to the original servo I assembled in the 5th grade, the East RC servo, and it was so analog. It just had the potentiometer, and it had a 555, and basically you set the 555 up to every time the 60 hertz pulse train would come in, it would charge the 555 for the duration of the pulse width, and then that would set the set point for the servo, and then the potentiometer gave the feedback. So basically, it was updating control loop only as fast as the timing signal came in from the receiver at 60 hertz. But I think, Scott, if I understand what you're saying in what I've read, on the digital ones, it'll accept the command for the servo at 60 hertz, but then based on that, it'll sample the motor and the feedback loop for the servo much faster than 60 hertz.
Right.
So it'll just take the last command, and then if it's off by a little bit, I mean, that loop will have a much faster response time because it's sampling much faster in between commands from the receiver.
Right.
And if anybody needs help with that, I've written code for the PCA 9685 in both C and Python.
Yeah, I will say this too.
Yeah.
I want to correct that the MG996R is a digital servo. MG stands for Metal Gear. 996 is a particular model. The originals were made from Tower Pro.
So I have
they are digitals.
Since Carl brought question, I'll throw out to everybody. I ran across this in a white paper the other day. Do you know why it's called a 555? Anybody?
Yeah,
Make it
So
sure.
there's three 5K resistors in series, and that's where the trigger, the
Oh,
feedback, and the reset comes from. So it's basically like a charge circuit through three 5K resistors.
Isn't that amazing? Can you
I was
imagine
gonna say
how many billion of that circuit have been manufactured?
Hmm.
Unreal.
Yeah.
So
and how
it
many
wasn't-
5K resistors is that?
Yeah, how many have the 3 5Ks? But still,
so it was either that or the 554 was already designed or something. So, you know, the next logical part number was 555 or something.
Well, or, you know, they didn't want to call it a 4.7, 4.7, 4.7. You know,
Yeah.
that'd have been
Marketing.
difficult to say.
Yeah, I'm sure more of those have been produced than any other part in existence.
no doubt.
Oh, I don't know if anybody saw it on the news, but a tractor trailer that was a U.S. postal delivery truck went off of I-75. So if you were hoping to get something in the next couple days, like I am, it's supposed to be here the 22nd, you may never get it. So
Whoa.
Right at I-75 and up near McKinney, right?
in like Stacy, I think, near
Stacy,
near the
yeah.
Allen,
Stacy
I think it
exit.
was, yeah, an Allen.
What's
There's
that?
dash cam video of it. It's pretty
Yeah,
wild.
I think the driver died.
But it
So.
looked
Yeah,
like it was going out of town instead of in town. So
Say that again.
I was saying looked like it was going out of town. But it's not a matter of, you we're sending something out, you might have a
Well,
problem.
Oh, I don't know. I don't know where he was going, but I was thinking, oh no, he's going to the Blue Ridge Post Office. So I'll never see
Michael
my bars.
Goldstar, nicely done.
Yes.
Thank you. Thank you.
I think that's 2 gold stars so far. That's pretty good for tonight. I think next in line we have from the list I had Harold, Doug P, and John G. So Harold, are you ready?
Yeah, I'll apologize before I start. I'll give you a clue as to what I'm about to ask. So I've been doing this balance bot thing, and everything's been giving me fits. I've had the stuttering servos, and so a couple of things. I've basically, at the moment, shelved the servo stuff and put some tie wraps around them so they're locked into a static position because I got tired of dealing with them because it's stopping me from making the balance thing part happen, dealing with that stuff. So I got to that. I got an IMU, reading that, doing all those kind of things. And now I'm up to a point where I need to start worrying about PID loops. That's why I apologize.
Oh no.
So I am not Murray. I am not proud. I don't need the most optimized thing on the planet. In fact, I've been looking through this and I've been watching, my people on the Twitch have helped me a lot in their searching things. And, we've got some great Google food going on and a few other things. And we found a lot of balancing robots. Some of them balance better than others, that sort of thing. And this is the sad part for me. They all use the same damn code. I mean, literally, every one of them is using the same code from 10 years ago. And I'm like, I'm not, you're going to say, well, you whippersnapper, now you're just whining. No, I'm not really whining. Well, maybe I am. But I started looking around and that just upset me so much that I'm like, you mean you're telling me we can't do this any better today than something was done 10 years ago? I refuse to believe that. So I started looking around for some different libraries. I found one that's being updated actively called Quick PID or something like that, and a few others. So my question is, do you guys, because you are a fount of knowledge, There's no two ways about that. When you're doing these pit top loops, because in this case, all I really care is on the y-axis, I want to zero that thing out currently, that kind of stuff. And so that's my input. And when I'm doing these, when you're doing these pit top loops, are you pulling from some library that you like to use, or are you just recoding them from other stuff that you already have? And I'm not judging either way. I just want to know how people are currently doing it, because in my brain going on here, it seems there got to be a better way to do this. There's got to be a lot more easier ways to do that than a bunch of Arduino code that's shifting bits. I'm not afraid to shift some bits. I've shifted a lot of bits.
Fiery, deadly crash in Collin County.
Oh, I got a lot of shit. I got a lot of shifting of bits in my past, so I'm not afraid to shift the bits. It just seemed, and I've got another slight concern. The people on my Twitch, I don't know, not necessarily. I'm not trying to make it easy for them, but I want to code this so I can understand it, so I get a new, fresh model to stick out there where people can go, yell at me 10 years from now, going, "Why can't you do this better than you did it?" and that kind of thing. So that's kind of my question, if that makes sense of a question. Do you code it yourself, or do you have some libraries you really like?
I'm going to put a link for my favorite library in the chat as soon as I can find it, but let's see what everyone else says.
Well, Harold, I have I actually flip-flop between two. I have one that I wrote myself based on, just like you did, research of how it's always been done.
Yeah.
And then I was using the CMSIS PID library for a while too. I found that the more mass you had in the system, the more the library was favored, versus if you have a lot of gear and you don't have a lot of, you don't have to electrically overcome a lot of torque, right? In other words, like even Burp is 20 pounds, but you've got a planetary gear, and so there's not a lot of what would be considered mass in the system from the control perspective, right? In the same way, even with decel, which seems to be the harder part with controlling it, is to decel it accurately. Driving it and getting it up to speed is easy enough, but that's where I tend to have more problems.
This is the amount of mass I got going on right here.
Yeah. So, and typically in the robot community, because I deal with this with elevators, right? And we're talking 80 to 100,000 pounds of mass that
Yeah.
you're pulling around. So the PID loops make a lot more difference there, especially like the D terms. And typically in mine, I use a little bit of P and a little bit of I, and my D term is usually turned off.
I got you.
Because I want it as responsive as I can. And since there's, again, all the gearing, you don't get the advantage of how that would smooth out an oscillation, right? Because that's what the D term is going to try to do, is to slow down any changes, whether they're, slowing down or speeding up. So, that's kind of my approach. And like I said, I've done it both ways. I've run, Burp both ways. And like I said, right now I'm using my own traditional, last error, what's the current error, and all that. So, but I do know the thing that is important is if you don't have a timing factor, because the whole idea is that this thing is done on a consistent period, right? And if you can't do it at a consistent period, then you need to have some sort of timing variable to adjust that, okay, this is, because I do mine in 50 millisecond, cycles or periods. So, and it's just easier to do it that way than trying to adjust for a 40 millisecond period versus a 50. You can do it that way, but again, you have to have a timing variable in there to scale everything. That's also an important issue with controlling the PID. So that's my take on it.
Okay, so from what I heard, Scott, what I got going on here, I need to be really consistent in whatever my main loop, whatever I can run that at, because and all the other stuff and that I have to get going, I need to make that main loop as free flowing as possible, so I get the same basically period out of
Right.
my loop. Okay.
Yeah, it needs to be the high priority thread, or, you know, like you said, in your main loop.
Yeah, this is the nano, man. I got one thread, and that's about it. So,
Yeah, I say as pointed out, the timing is what's really critical. And so what you probably want to do is have a timer so that with an interrupt, and on that interrupt is where you capture the data.
yeah,
And
I get that. I
then,
got it.
then as quickly as possible, you compute the results and feed it back, because the delay between when you read the information and when you set the new values is also an important parameter.
Yeah, I mean, that's a good point. I do mine in the same loop. Basically, I get my feedback, I process the feedback, and then I update the PWM, all in the same thread, basically. But yeah, I mean, you don't want your velocity information or your position information, however you're doing it, to become stale, right? I mean, you need to react to it, and doing it in the same thread, then it's always at the same time.
Yeah.
Right? So if you have that thread running, consistently, then it's easier to just calculate it all at the same time.
Gotcha. At least I think I got you.
Okay, Carl demonstrated how to keep the timing consistent in one of the meetings earlier. I don't know how you'd find it. I don't know, but Carl actually showed some of his code to how he kept his loops triggered on a
I tell you how I find it. Hey, Carl, where's that video?
Where's that video? If only we had SEO.
How would you do it now? I just get Carl on the phone, or if he's got time. That's how I find that information.
Yeah, I don't mind showing it again if you wanted to see it. But it's the same pattern I've used since various members of the club helped me get set up with Arduino interrupts. Did you want a quick summary of it now, or?
Yeah, as long as I'm not boring anybody with pit talk, because
Yeah. There's also a very good article series that somebody did on the design of the Arduino PID that talks about how to actually measure things like the integral term and the differential term, so that you don't get weird things happening.
Yeah, if you get a link for that, that'd be awesome.
I can't find that right offhand, but I know there was, and it was about a 3 or 4 part article where he talks about each of the terms separately and what some of the gotchas are. I'll see if I can find that and put it in the thing.
I think another common problem that happens, Harold, is, typically I'll ramp up the demand, because you also want to avoid any huge steps in your demand, because your PID is supposed to handle that, but that's where the PID gets challenged, right? So if you step it up, or actually accelerate and decelerate your demand, that you're feeding into the PID loop, it's a lot easier to tune and a lot easier to keep stable.
I got you.
Yeah, one of the points that he makes in the article is, rather than the differential term being the difference of the error, is that it's the difference of the actual motor. In other words, he's essentially dampening the motor, not the error term. Am I making sense?
Yeah, yeah.
So he's measuring what the the rate of change of the motor is, not what the rate of change of the error is.
Well, what value of the motor are you talking about? The velocity of the motor or the voltage?
The velocity.
Well, wouldn't that be the speed error that's coming in to the PID loop?
No, because the error is the difference between what the motor is running at and what your command is.
Okay.
And if you do a step in the command, you'll have a step in the differential, which is not what you want.
Right.
You see what I'm talking about? So what you do is you measure the rate of change of the motor, not the rate of change of the error term.
Oh, I see what you're saying.
Does that make sense to you, Harold?
Yeah.
So what you're doing is
Well,
you're
the problem is this: I don't have encoders on these motors, so I've got no way to know at this point.
okay. Well,
Yeah,
You're measuring angle, aren't you?
I'm measuring angle. I'm watching angle. Basically, as in this case, the way the IMU is mounted, I'm looking at rotation of the x-axis and that kind of stuff on that. So at least I believe that's what my input value should be, because y is front to back on the robot, and my x is what's going to be the stable part.
So you're using the accelerometer then,
Accelerometer.
not a gyroscope. But
Yeah, I don't know which one to use at the moment. I have access to both, and I thought that maybe at some point the combination of those two would be something I need to do. But that's why I'm asking you folks.
now the other thing, Harold, is that Paulalu makes a balancing robot.
Yeah,
You might want to look at what their code is.
I'll go look at that. I'm not going to say I've seen that code already, but I feel like I've seen that code already. But I'll go look at Pololu's. I'll look at that. One of the problems I have, this is another one of the problems I had that I ran into, is that everybody running this code is specking header files and libraries that don't exist anymore. I mean, literally, you go to the GitHub repository and it's not there, or won't compile, those sorts of things. And I'm like, I don't want to debug 10-year-old code to get it to compile right now. That's not the problem I want to solve. If eventually I have to solve it, I will. But that's not where I'm just what I'm trying to avoid.
Well, the thing is that I actually have one of those Pololu balancing robots and the code that runs it, and it balances very nicely. And so I would think that would be a nice starting point.
Let me go
Something
look.
that works.
Or Mr. David Anderson has had a balancing robot for a long time, so
Yep.
his seems to work very well.
Isn't he the balancing king?
Is-
You need a king.
Yeah, where's David when you talk PID?
how do we miss that blue?
He's there. He's just listening quietly.
So I can't share the balancing robot, but in terms of just understanding how PID loop algorithms come together, and some of the like this one library that I mentioned that Doug gave a +1 for, it's a pretty cool library in the way that he has this multi-page blog. It's pretty old, but it shows you how the PID loop comes together and how different parts of the code add different features and take care of some of these effects that everyone's talked about. But then in terms of the timing, Harold, I think you're asking, so the approach that I've used is, and this, I've only done it in Arduino, not Pi level stuff, but so I have the setup and the loop, right? So if you look down to the loop, my loop in the Arduino is quite simple. If a 20 millisecond interrupt is active, then I go through these tasks and I set the flag to false. So this thing only gets set to true whenever a hardware interrupt is set.
Yep.
And that hardware interrupt is set up via in the setup here. I initialize timer 5 to periodically set that flag true.
Flag, yeah.
So I initialize it with these registers. The reference to how to do it's there. Got to credit Dale Wheat somewhere for some of these settings, but that sets the 50 hertz timer. And then from then on, once that runs, it just sets that flag high. And where is it? That's the
Yeah, that's what I was envisioning, and that's what I've kind of started coding up on the thing to be able to use the interrupts and timers to set.
Yeah, I found it works really well. I mean, I've used an oscilloscope to measure, and it's got as low a jitter as I can imagine. Because the only thing that's varying is whatever the Arduino middleware is doing.
Yeah.
But all the ISR does is set that one pin to high. It sets that flag to true, and that's it.
Yeah, in fact, I was doing some reading about that too, because of this very timing thing you're talking about. Whenever that ISR kicks off,
yeah,
you want it to be do as little as possible and get it back out of the way, because I remember back in college days going through microprocessor design and all the other kind of things going on. As soon as you hit an interrupt, all the other stuff gets to wait a little while.
Yeah, it gets you
don't want it waiting any more than it has to, right? So
and because the way I view it, because because this function right here can be interrupted, right? It's just user code in Arduino can be interrupted. So what I do to minimize the effects of that jitter is in the design of my 20 millisecond main loop. Basically, I have almost nothing, and then I have basically time slices. And the very first thing of any merit in each time slice is to sample the IMU. So basically, I'm sampling the whatever I measure, in this case heading, with as little jitter as possible, because as fast as that interrupt can enter this routine, it writes a few pins, no variance, and then it samples the IMU. And then from there on out, so the measurement to generate the error, that computation is always as accurate as can be.
And then you want to make sure that the first thing you do is use that value to calculate what the PWM value needs to be, because any delay between when you measure it and when you control it is going to cause problems.
Yeah.
Yeah. So I do that in the same interrupt, or the same 20 millisecond period.
Well, it's not so much that you do it within the 20 millisecond period, it's that you do it right at the beginning of that period. That is, any delay between when the measurement is taken and when the control is applied is a delay in the loop.
Yeah, yeah.
And that will unstabilize the loop.
Yep. It looks like an integration in the loop, or an integrator in the loop.
Yeah.
And that can be the kiss of death.
Exactly.
If it delays too much.
So Harold, does that give you enough information to choke on?
Yeah, I got to try some things. And
Harold, what IMU are you using?
I got a 6050.
Okay. I was going to say there's a lot of 6050 code out there.
Yeah.
I'm sure you've seen that.
I've seen a lot.
Yeah, but there's levels of it too.
Yeah.
So if you can use their secret sauce that you have to, I don't remember how you get it, but it's an assembly program that only they can provide it for you. If you use that, the 6050s actually steps up a whole bit. It's a lot better than it was, where you can kind of use it in a sloppy way where you don't use their secret sauce.
Well, they've got this thing called a DMP.
Yeah, that's what I'm talking about.
Yeah.
Yeah, if you use the DMP, and like I say, I really haven't used the 6050 a lot, but I have seen code both with it and without it, and you'd rather be with it.
Yeah, it seems like that DMP helps you a lot when you're figuring out whether things have moved or shifted and raising events. And hey,
I want to say it's a Kalman filter, but I'm not sure.
Yeah, and you can set, and I got some filters I can set both high and low, and that sort of thing there too to weed out stuff. And I'm still exploring what those are.
So if you run into code that doesn't mention the DMP,
yeah,
probably move along.
Probably move along. Okay.
Yeah,
I will take that. I will take that advice for sure.
yeah.
Yeah, I was thinking David Anderson, his code may be 10 years old. Maybe he was one of the original writers of it, you know.
He might have been. I literally, I mean, when I you know, I know I'm whining. I do that. I do know that. But I can tell you that I search for, doing lots of searching, and I go find the code, and I'm like, oh, I've seen this exact same variable name, exact same everything. It's a copy paste, they didn't even change anything else. And I'm like, okay, another one. Hey, I did a balance spot here. Come check it out. I'm like, it's the same code the last guy used. It's not necessarily the last guy, but the last person I looked at, and then I go do this one. Oh yeah, it's got a get up. That's 10 years old, and it's doing the same thing these guys did last year.
Yep. It's like blink LED, huh?
Yeah, exactly. And I'm like, somebody's got to be. It's not that I can't understand it. It just there's a lot of, and I'm going to use the technical term here, gobbledygook in there that makes it confusing for new people to come and check this thing out and figure what's going on. Yeah. And so I would like to help the situation a little bit when I finally get this thing balanced and out there. If that makes any kind of sense at all. I'm not looking at
I just put a link in the chat on a guy that has a library apparently with a very simple documentation on using the DMP on a 6050.
Okay, I'm looking it up.
And also, Errol, when you say a balancing robot, that covers a lot of things.
Yes.
A lot of people say if they basically have something that doesn't fall over, that's a balancing robot.
That's my definition of it right now, but we'll see.
But if you look at David can drive to something. He can turn. He can, let's see, what is this? I want to say when he detects, he can drive around objects. I mean, his is almost like a differential robot. Okay, so I mean, it works differently, but what I'm saying, he has all those features. But a lot of these, I made a balancing robot. All it does is this. And maybe it goes forward, but that's, some of them can't even get him to turn.
It's an inverted pendulum that works in one plane, right?
Yeah.
Can't
so
turn.
You got to be,
So I can tell you what my ultimate vision would be with this little guy is that I get up and where'd he go? Where'd he leave me? No, you didn't leave me. I just don't know what screen you're on. Well, it doesn't. I can't. Oh, there we are. So my ultimate vision, if I could be perfect in my head, I would like the thing to stand on its own. The eyeballs are after an ultrasonic. So if somebody were to put their hand in front of it, it would back away, to a comfortable distance, what that ever is. And I would like to attach a Bluetooth module into this, and be able to from my phone using the standard. There's a 4-button and a controller that Adafruit has already built that knows how to talk to send button 1, button 2, button 3, that kind of stuff, and be able to drive it around in a very simple fashion. I'm not doing cartwheels and I'm not doing acrobatics, but that would be the ultimate thing that I would like this little guy to do. And so,
if you can get David to talk to you though, on, he
sure,
could
because
really
I got
give you some big ideas.
yeah, I got some sneaky suspicions that when I want to go forward, I've got to trick the offset of the thing so I get a little out of balance, just enough to start rolling forward. And then if I want to go forward and turn left or right, then once I get the balance number, I have to slow down one of the wheels or speed up one of the wheels, depending on what's happening at some ratio that I'm sure is going to require lots of headaches, that my little guy is going to fall over and get bashed upon it. So good thing it's a 3D printed thing. So,
I like the personal space idea. You're in my personal space. Please back up.
Oh, one of my VIPs, one of my followers on Twitch, got up and said, "Oh, in B, because it's BB Pi, it's BB dash 3.141596, but we call him BB Pi for short." And he goes, "Hey, we could put a music thing on it, and BB could play music himself." And there's some cat out there that's used the numbers of pi and used like different combinations of the digits to represent, not different combinations of digits so much, digits in groups of 2s and 3s and in an interval to then drive notes and chords on a piano, and it has some funky music out of that. I'm like, well, yeah, okay, let's make him stand up first and more. I do appreciate that, because I mean it's a cool idea, cool funky idea to play with. But yeah, but I'm sorry I had to bring up kids and stuff. I truly am.
You don't need to apologize. That's part of the fun of this, right?
Yeah. I was just wondering if stuff, and you guys have got me. I'm going to go crack open every one of these and have them in my.
Have a look.
Yeah,
Keep you busy.
Yeah, but it's going to keep me busy for a little while. I'm also over here coding up on my they call it a nuclear football, but basically it's here.
The big LED briefcase thing from Code.
Yeah, the big LED briefcase. I saw pictures of it in action, and yes, it's bright. People are doing this number on a darkened stage so they can actually see something, that kind of stuff. And there's a contest. I think it's an Instructables or Hackaday, one or two. Is a contest. I think I got till October 1st or something along those lines. That if you do something cool with our LEDs or something, it's a $500 first prize, and it goes down from there. And so since I've already built this thing already, I might as well document it and do all the stuff and enter it in, which I'll be working on it. So now I've got to do different lighting levels of stuff, like banding things around and breathing lights and stuff. And I've got a few formulas I found for both the circular, quadratic, triangular type breathing type to control all of the brightness levels and stuff and that kind of thing.
See if you can make waffles with it.
Well, I might be able to. Oh, what I can also show you is this. So I'll show it to you real fast. So this guy right here. This is Adafruit's application. Runs on your phone, and it talks to their Bluetooth or Windows. So I've got the code running, and you can see it light up and light up with blue over here. And now I have all these kind of things. Now this thing doesn't have an accelerometer, but if I did have one, I push the accelerometer. Maybe I asked for too much. Yeah, no response. But if I did have something that understood, I could use all those things. Currently, all I really care about, really? Come on. All right, come back here.
Incidentally, I did find the tutorial that I was mentioning. and put it in the list there.
Okay, I'll go pick it up. I will go pick it up.
It's a whole series. He talks about the improving the beginner's PID.
Ah, okay. Well, I'm definitely a beginner. So, so the idea is what I am doing is see the, come get out of there. If I go into the controller button and go to control pad, you see I've got a little control pad there that I can use on the phone. It's already built up. Buttons 1 through 8 on this, and you need to map button 1 to something and button 2 to something and that sort of stuff. And the library already understands the protocol talking between the phone and its library on the Arduino. So you can take all that kind of stuff and then use it. The other thing that has that I'll probably be using is a color picker. So allow it to pick a color, shoot it down to it so I can change the color of the lights and that sort of stuff. So with them 8 buttons, I think I can give him 8 different patterns or 7 different patterns, and one of those buttons make it to go through all your patterns in some kind of a loop. That kind of stuff. Sort of the idea. He's going to freak out on this. He's already freaking out anyway. And now the thing we're talking about, how do we get coming out of this thing when we open it up, on stage? Like, let me get it flashing the way you want it first. Let me turn it to 11 before you turn it to 20 on me. That sort of stuff. And so anyway, that's as he's playing, and they've been real impressed with it so far. And I'm not saying, I say the thing is, we blinked an LED as far as I'm concerned. Yeah, we got probably 10 amps and stuff running around there with all the different things going on there. But I'm just glad it didn't burn up on them, let alone, because we do have a lot of amps flowing down there. It's got a 2-cell battery. 2-cell? Yes. Yeah, I've got a 2-cell battery working on there. And so it's not all that juicy, but at 5,000 milliamps, if something goes haywire on that kind of thing, I could easily smoke something, but not a problem,
While you're talking about things on the cell phone, one of the things I'm looking for is I've seen where somebody has in effect, a joystick for a cell phone that they did by using a HTML with a JavaScript, so that it was essentially the slave sends that page over to your cell phone or whatever unit you're looking at. And it has a joystick, essentially a dot in the middle that you can move around. And it's all done in HTML and JavaScript. So it's, anything that can run a web page can run it. I've seen that it exists out there somewhere, but I haven't been able to track it down. So if anybody stumbles across a good write-up on that, I'd appreciate it.
Okay.
Cool. I think next we had in queue, we had Doug, and then John. Anyone want to go in queue after that? I think it looks like, Doug, it might be your floor.
Okay, give me a second here.
All right.
I've got to do my diabetes monitor here since I'm drinking wine.
Hey, Doug, I assembled your Pi control board while we were waiting.
Oh, God. Fantastic. Wow. Thank you.
Just need to find a way to get it to you.
Okay. Well, I'll send you my address through the email. And like I say, if you need any money, just let me know. I'll hit your PayPal. Okay. Let's see. All right. What I wanted. Let me count this out again. This Saturday is the 24th. And then there's the 1st. 1, 2, 3, 4, 5, 6, 7 weeks to Robo Columbus. So things need to start hopping and hopping. Okay, so a couple of things I wanted to show. One thing I was kind of happy to do. Remember last week I said I was going to do a follower? Well, I got part of that. Let me get my thing unwrapped here. Let's see what we got going here. All right. Okay. Yeah. So what I did and what I'm going to show tonight is essentially a follower, but it's not going to roll on the front. So it's only a black star. But there's a bunch of cool stuff that I did. Okay. Okay. Can anybody see that oscilloscope? If you go ahead and pin my window. I want to try and do this without presenting.
We'll pin Doug's window and Dave Beckley, I'm gonna mute your microphone because your audio is coupling in.
Okay. So you see the oscilloscope there?
Yep.
All right. Okay.
Yes.
Let's see if I can get this rigged up. All right. Now, okay. So over here, you can see I've got the OD light. All right. Right here, I have a Raspberry Pi. Right here, behind this thing, is that board that we were talking about earlier, the 16 channel
Servo driver.
servo driver, right? So if you, okay, now, let me do this.
Is that a piece of robot plumbing there?
Oh yeah, okay, let me hit
Gotta
that
have robot
first.
plumbing.
Okay, so this is really cool. Okay, so what you're looking at here, I'm going to have this is a GoPro, but it's going to be mounted up on a mast. Mast is going to be this 1-inch pipe right here.
Yeah.
Okay, and this is the part that's going to be mounted in the actual platform. So you have this fitting here, and then the platform would be right here. Then you screw this in on the bottom, okay, and this probably be cut less, but let's not worry about that. So that's your mast base, so that the thing can actually be taken in and out. You can just literally pop it out. And then this is a clamp from Thingiverse that I guess I could put that in, but it is really, I mean, that's really, it's almost perfect. So what you're going to do is you put this on your pipe, and then you have your mounting plate right here on this platform right here. You can see that I've put in brass inserts, so you just screw it in, and you can easily position it up and down the mast, providing that you have leads long enough to do it. So, and then you might say, well, what's this? This is going to be the top. That really looks weird. Well, I mean, what you going to get out of that? Well, this is something that I've done in the past. First thing I'll do is slit this right here. Then I'll use my hot air gun and I'll work these two halves flat. And then when I've got them nice and warm, I'll smush them down on the desktop, and it'll form a flat plate. If it's not perfectly flat, I'll use a sander to finish off being perfectly flat. And I use that as my mounting plate. So that's what's going to happen there. You can see I've been working on the base. The original base again, to give you a feel for it, the original base, this is what it was, the size of it. Now you can see it's a monster. And I've decided to use this OtterBox here. It's got 2 clamps on it, and it's actually going to mount underneath this plate here, and that's going to power the Raspberry Pi. And then I'm going to have my favorite, where is it? My favorite battery elimination circuit, BEC, which this is the one that I always like, which is a UBEC from, I think it's Skyfly or Hobbyfly or something. Hobbywing, I'm sorry. Hobbywing UBEC. These I found to be very reliable for 3 amps. Okay. All right, back to the presentation. So what I've done is I've hooked onto channel 15, and on channel 15. So if I show you what's going on, I'm going to do this. Sure. Yes. Okay. And here you can see I've got 2 cones in field of view. All right. Now, if you're looking at my window that has the oscilloscope on the scale, there's two cones being noticed. Now, what these 4 numbers, the one that starts with 0, and then it looks like a number in the 82s, and then a 178. The 178 is the
One on the far right, usually.
is the degrees that it is picking up. So right now it picks the cone with the highest value, the highest confidence level. So right now it's picking up this one where my hand is, this one over here. All right. So if you see, well, now it's picking this one up over here. So if I cover this guy up, did you see that? Did you see the oscilloscope cut down?
Mm-hmm.
I can't hear you, so I don't know. I assume you said yes.
Yes.
Somebody say yes real loud so I can hear you.
Yes.
Now, if you go to the other one, cut it off, you can see it goes to the high value. So if I take one of these guys and put them out and slowly move him back, you can see the servo number changing with position of the cone. Okay, so what's going on here is it's actually tracking. So what happened in the development of this is I got it to this point, and then I said, okay, and it's time to move over, and actually I had no way to power the servos. So I went ahead and started working on the superstructure. And I went ahead and told, this is something I've shown before. It's two battery terminals, and all there is in here is 2 pieces of copper that are soldered between the leads, and then these little things are put on there. So now I have three power takeoffs that I can use, and this just fits in line with the battery. I'm also making a similar one, which will be a switch one for main power. So you'll have to flip the switch before power will be available. So I'm working on, like I say, superstructure right now. And
so what are you using to detect the cones? Did you create models and Do you have any
Yes.
eye?
Yes. Yes. And, you know, hold on a second. I'm going to get rid of, as soon as I figure out where I am. Okay. So what, yes, that model, by the way, if anybody else wants to contribute to it and go it, it's on RoboFlow and it's available. And basically what I've been doing for the last couple of weeks is walking around, putting cones down and trying to get pictures from the internet to broaden its appeal. Because most of I only have a couple of cones, so I keep getting the same picture of cones in different situations, in different lighting conditions. But to broaden it out, you have to have, different color cones and all different shaped cones, cones with stripes, all of that. If you want to be able to pick up those type of cones. Right now, since we're really only looking for one type of cone, I feel more comfortable with pictures that I'm taking of that type of cone under different conditions. And I think now I've, with variations and whatnot, I'm up to a lot of pictures. Okay. So
It's the Where's Waldo of traffic cones.
yeah. Well, there's other traffic cone models available out on the web and also other public databases. I haven't really tapped into them because I'm not really sure yet how to handle, since a lot of them, it's the same thing that Harold ran into. There are a lot of them are using some of the same type of images. So I started off with the gentleman that I mentioned earlier that had a traffic cone model, and I started off with his model. And then after I ran that one, I wanted to use the Oak D Light because I have Movidius in it, and it makes it faster, much faster. You saw it flipping along. So, and then I started making my own, adding my own pictures to his model to try to bring the numbers up to a more satisfactory number. And there was a couple of weeks ago, we talked about an OpenCV tutorial about mistakes you can make taking data. And I've tried to follow his don't make mistakes. And if you haven't seen that, I'm not sure if I got his link. I probably should have put that in here, but his basics things was, to make sure you go through every image in your database to make sure that all of in this case, I'm going to only have one class, traffic cones, that all the traffic cones are marked, that you don't skip a traffic cone because that'll screw your model up. Also, don't use multiple images from a video, because if you use multiple images from a video, there's not enough variation between the images that you're actually reinforcing that particular the pictures that you took from that video are being reinforced over the other ones. So essentially what he says, don't use highly correlated images. If you're trying to cover hard cases, which I don't think we really are, but let's say you wanted to cover cones at dusk and cones and probably shade and bright light, and that's probably about all we're really doing. We're not even doing in rain, okay? Even though that could be a realistic environment if in a contest.
Let's hope it doesn't rain.
Yeah, but I'm just saying. So if you want to cover those extremes, you have to have examples of those extremes in your database. And also you need to make sure that the images that, like if you have what I call an imaging section. So I go take my camera, I go out with my cone, set it out in 5,000 different places and take 2 or 3 pictures around different angles. Well, but that's a set of images. All right. And when you do that, you want to try to make sure that they get split properly between the training and the validation and the test sections. Because if you don't, again, you end up with this biasing of the data set. And if you have multiple classes, you got to have samples of all the classes. In our case, when we only have one class, that's less of a problem. But I do add what they call null images. And null images are images that don't have a cone in them. And they're marked. You can't just stick them in the database. You actually have to annotate them and say they're null. And you have put those in there. And he says, whatever you do, review all your annotations, especially if you're using other people's public databases, because there's a lot of mistakes out there. So, and every time you have a mistake, that squirrels your model a little bit. So anyway, I'm trying to follow his instructions and trying to get these out there. Is it the best model in the world? No, it isn't. But it does seem to be able to pick up orange cones without too much of a problem. So we'll see how that goes. So,
and what deep learning software are you using?
Okay, I'm using RoboFlow is on the web. It's a web based. They have their models, okay. And as you get more advanced than I am, you can pick the model. They have a library, a model zoo, and you can pick which model you want to work from. But I'm using pretty much their default model. Okay. Is it the best? Probably not, but it's damn fast. I'll tell you that. And so I think for me, it might be better to try to figure out how to get more images. Keep building the database of images. I think that'd be the strong thing. So like Ray's using his light sensor, and I did move mine to his lens. I did put his lens in my.
Oh, you got one, huh?
Yeah, I looked through my old lenses and I went to Tanner's too and said, "Oh wow, they're only 20 cents. I'll buy 5 of those. I'll buy 5 of those." So I got 5 of them too. So
together we kept Tanner's alive all those years.
So anyway, so I put one of those in there. I didn't see a whole lot of difference, and I'm now beginning to wonder if, so that's, if I remember right, that's an 18 or a 16 millimeter lens. It's not a real super big lens.
No, yeah.
And getting it properly focused and everything, I think is probably key to peaking your thing. I also, for Ray, if I can find it, I'm going to do another presentation just for a second. Okay. Okay, I did run into this. Let's see if I can find it. There it is. There's this optical filter.
Yep.
It's the 615 bandwidth. Is this the one you're using?
It wasn't from eBay, but 615. I think mine was actually 630.
Okay. Anyway, here's the peak, and if you look at the peak, it's between 600 and 630 from the looks of it. So this might be just below yours, and that looks awful like what we're trying to hit. You can see it there. So anyway, I'll put this in there. They only have 2, as they say.
Yep.
So
Yeah, I think the color sensor, the center is actually around 600 for orange.
Yeah.
But I've found 590s and 630s, but not exactly 600. So I don't know if that's a custom lens or what.
Anyway,
But
I put it out there for anybody who wants to look at bandpass filters. There's one there. I think that's pretty much what I wanted to cover. Like I say, I think the big thing to realize is that Robo Columbus is rushing towards us, and we really need to get this robot on the road. Sounds like Ray's pretty much, he's probably over the hump, but we'll see. I got my ground plane.
for you.
Yeah, it's a 6-inch aluminum plate. So we're going to be using that. Going to be using that with my U-Block M9. So now you notice a big difference on this robot from what I've done in the past. In the past, I've used Autopilot, and I still have that robot sitting up on the shelf, but I'm not working on it right now. My intent is to make this. It'll have U-Block 9. It'll have a BNO 55. It'll have an Oak D Light minimum. It'll have some sort of, I'm still debating on what sort of obstacle avoidance stuff to do. I'm still leaning towards an ultrasonic, at least in the forward position. I have a Benny Wake, the micro mini that I'm thinking of using. And one of the things,
too.
I'm thinking I might put that on a servo, and it'll look forward 90% of the time. But if I see an obstacle, I might follow the obstacle around with that instead of, or I might do that with a servo too. I'm not sure. So obstacle avoidance is still something I'm not quite sure about.
I might use the touchy-feely approach where I'm just using my bumper switches, where ooh, yeah.
Well, I'll just tell you, I did that once with my other one. And I hit a tree.
Yeah.
That bumper wasn't any good.
Oh, really?
Yeah, it was like, luckily it didn't break any of the suspension parts, because with my Vandals now, they're not being carried by Hobby King anymore. So spare parts would have to be either substituted, or they'd have to be 3D printed. So that's a problem. So I don't want to break anything. That's one of the reasons why on my new base, I literally put the cover so that if it hit a tree, it'll hit the bumper, but before it hits the wheels, it'll hit the actual top, which is mounted on 3D printed parts. So in an extreme case, that would break. The supports would break off. But and also using an 80 turn RC motor, brush motor now to slow the thing down. So we'll see how all this comes together. And power wise, I'll be using separate U-Becks for the servos, and the GPS and IMU will probably be on the same one. And the Raspberry Pi will actually use an OtterBox power source, those things like you do to recharge your phone. It's going to be on there. And so, like I say, might throw the sonars on the same one as the servos. I don't know. I haven't made up my mind on that one. But I'm going to try to separate everything. I want to try to make them modular too, so that once I develop, there'll be a lot of microprocessors on my design. And what bus I use is still right now, like I say, you saw that I can track with the Raspberry Pi. Now the question is, do I want to track with the Raspberry Pi? Would I rather have that offloaded to, say, a Teensy or even a Mega and do it there, where it might be easier to integrate the BNO 55 value inputs and the distance and heading values from the GPS. So, and there's one last thing that I don't know if I'll get to or not. On my other Vandal, the one that I have used in the past, I had a motor shaft before the differential encoder, which allowed me to control motor speed. I could have a PID on the motor motor. I couldn't tell you if one wheel was spinning and the other wheel was sitting still. I couldn't tell you that, but I could tell you how fast the motor was turning. All right. So, and the ideal thing would be to have two encoders, even if they're low resolution. And I mean, even if they were like one magnet stuck on the edge of the rim, at least you would know whether you were stuck and you could do something with it. So we'll see where encoders are still, not sure what I'm going to do there yet. Scott's still on?
Looks like it.
Scott, where do you have your encoders?
They're on my motors.
Okay, because you're a differential, right?
Differential steering?
Yeah.
Yeah.
Yeah. So, yeah, that's one of the advantages there is you can just use the motor. If the motor says it's turning, it probably your wheel's turning too.
Well, Scott, isn't yours more skid steer?
Well, yeah, it is now. I mean, it's four-wheel drive, so yeah, it'd be considered skid steer. But
yeah,
then Turd is just your regular RC car, like what you got, Doug.
Yeah. So that one, it was like I say, in mine, there just happened to be an opportune location where I could monitor the drive shaft.
Well, my encoders were built into the motors.
Mm-hmm.
Pitman motors, and they have like 512 encoders, and then I run through my gearbox. So I think my variable is like 6,900 counts per inch.
Yeah.
So it's a lot.
Yeah.
But really, to control the velocity out of them, you need a lot more resolution for that than you really do position, right? So.
Right. Well, that's what I'm saying. The drive shaft gives me enough counts to PID on the motor speed. Okay, I can do that. But that doesn't tell me whether I'm moving or not. It just tells me my motor's turning. Because I have a differential in the back. So if I have a stuck wheel, one wheel is spinning like hell and the other wheel's just dead there. So that's this would be a case where Positrack would really have been a better option for us.
So Doug, you're going to have all this done by mid-November?
Well, what you're seeing is I've got a lot of things partially done already. Okay. And I hope to,
From your description, it sounds like a pretty tall order to get done by mid-November.
Well, you got to remember, like a lot of this stuff is already done. IMU code and all that's all written. I'm not going to redo that. I have that from previous robots. The only thing that is really new on this one, and one that I spent a lot of time on, is actually the OD light. because in the past I've always used a Pixie. And who knows, I might throw a Pixie on there too, belts and suspenders and see what happens. But that's why that's why I went to the superstructure this week, because I knew I wanted more space. And I'm actually going to put, when I say I was going to have a mast, I'm actually going to have two masses. One's going to be a tall mast. That's the one with IMU on it. And that's the one that's going to have those brackets that I told you, the little green bracket I showed you. The ones that look like this, they're going to be on that big one, so I can have different things sliding up and down that mast. In the back one, it's just going to be a little stubby mast so that I can put things under that 6-inch ground plane. So I can have pieces, I can use that real estate on the board, on the platform underneath that, because that's 6 inches. That's a big chunk of real estate if you don't have anything that you can put underneath it. So I'm going to have him jacked up in the air probably 2 inches, not because he has to be, but just because that's what I'm going to do.
Yeah, instead of a bracket on the back, I just made mine friction fit. So hopefully they're not going to split. Could happen, but that's a open MVH7 mount that goes on the mast.
Cool.
So,
well, Ray, I don't know.
Got to have robot plumbing,
Oh, you got, yeah.
Yeah.
Now let me see if I can. I'm going to put a link in on the that Thingiverse if I can find it. That really is. It's a parametric library, so you can make a clamp for any type of pipe you have, and you can modify it yourself. It's really nice. I'll put that in a link here. I think that's pretty much for me, Carl. So, yeah, John, that's why I wanted your board, because I want to be able, since I'm putting a Pi on this robot, I want to be able to take them down gracefully without causing any problems. And also,
well, send me your mailing address. I'll get it to you.
Thank
you.
you.
By the way, on that GitHub repository, I also uploaded the KiCad files for this board.
That's good. Okay, great. Okay, let me get that link.
Cool.
Yeah.
It was looking good, Doug. Making progress. 7 weeks, huh?
7 weeks.
I think John G, maybe you were next in line if you wanted to do that.
No, actually, I didn't have anything.
That was it. Okay.
Doug was mentioning what I had presented last week on the software that I use with this board to control an application on the Raspberry Pi.
Okay.
And to be able to shut it down, all from, this, you can do it, everything you can do headless with your application.
Handy little custom board. Nice.
Hey, Doug, what kind of frame rate do you get off the Oak D-Lite using that model?
Okay, if you watch the screen, it's flipping around every 18 milliseconds.
Okay.
So it's fast. It's a lot faster than I expected.
I'd like to ask John. John, that little switchboard you designed that and had it built, had it made?
Yeah, I used KiCad to design it and had it manufactured by the board manufactured by Oshpark.
How much does it cost? Oh, go ahead.
Oh, it's a pretty small board. I think three of these boards cost some ridiculous value under $10. I think.
Wow.
From Oshpark. I mean, I can find the data real quick here.
Well, 18 milliseconds is like 55.5 frames per second. So yeah, that's pretty fast.
Yeah.
Fast enough anyway.
Yeah.
I'd like to, John, I'm impressed with you building those boards, and and that kind of stuff. I truly am. It's just for me, at the moment, it's going to require way too much forethought and planning versus my breadboards that I got going on. I do envy you, and I do wish to be you when I grow up some point, though. I truly do.
Well, maybe I can make a few more of these boards and make them available for the club.
Yeah,
That'd be great.
absolutely.
Hey, Harold, I'll tell you what, I used to do everything with breadboards, and then I learned how to do the toner transfer method of PCB making. And because you have circuit checking and other safeguards, I found that it was actually faster for me to draw it up on KiCad and test, make a board at home, I'd have it in an hour, and I'd wire it up, and I had no problems with bad connections or not leftover thing. It was so much faster. I don't breadboard. I mean, I don't, unless it's really, really simple, I don't breadboard anymore.
I got you. So when you're talking about that, you're talking where you do the etching the copper clad boards and that sort of thing to get your stuff.
Yeah, you have to get, what you do is you print out from KiCad the picture of the circuit.
You don't do that anymore?
Hmm?
Yeah.
You don't do that anymore?
No. So you're telling me I should just throw away my wire wrap setup, right?
I just looked up the invoice. It's $8.65 for 3 of these.
Wow.
boards.
Well, that's amazing. That you,
Yeah.
You get, I'm kind of curious of how you get started doing something like that as a layman, you know.
Well,
There's websites you go to and they kind of hold your hand on
Well,
how to do all that, huh?
okay, Mike.
Well,
Doug did a.
I want to do everything.
Doug
Now, hurry
did,
up because I ain't getting any younger.
Doug did a demonstration of that at the makerspace of how he etches those boards, and I actually used that technique to actually do a 2-sided board, and it worked out beautifully. And so the advantage of it is that it doesn't take 3 weeks or however long to get it from Oshpark. Now, yeah, if you get it from Oshpark, now you have plated through holes and all that good stuff. But to get something out instantly, it's very satisfactory.
Yeah, if you're comparing it against, okay, don't think of it as a finished product. If you get your breadboard right, you can go send it to Oshpark and get it built. You know what I mean? But if you want something to know, if I like to think that I can do it I can design a simple circuit and get it etched in an hour, no worse than 2 hours. All right. And if I have a mistake, first of all, by putting it out in KiCad, and I know I'm going to have everything hooked up. Now, whether I hooked it up right or wrong, myself, I might not know that. But
How do you spell that? Can you put that in the notes that I
Okay,
can?
well, okay. If you go out DPRG videos and you go way back, well, actually, it might be on the.
Oh, okay.
There's KiCad tutorials. Now they're old and they're not to the newest version. However, the ideas are the same.
Yeah.
And how to make toner transfer PCBs. I did it. Thousands of people have done them on the web. But if you want to see how hard it is, because I actually did it in the class. We actually made a board, and that's out there in the DPRG.
Okay.
Things
Tutorial?
too. Yeah,
In
they're
the
there.
tutorial section?
Yeah, what I would do is probably look up DPRG Doug Parody, and then it should, while you're on YouTube.
Oh,
and it
YouTube.
should- Yeah, go DPRG Doug Parody, and it should bring up the videos that I did in that series, or at least one of them. And then once you find one, you can find the others.
One of the things that always throws me about KiCad is how it locates its libraries. It's pretty clumsy, and I always get it wrong.
Yeah. Well, like I say, they've made it better than it used to be, and I want to say that they've even got now where you can download the biggest problem is when you had to go make your own footprint. And it's not hard, but
It takes a lot of practice.
yeah, and it's one of those things that every part that I had, a lot of them were, I got them surplus at Tanner's, and so that was the only way I could get a footprint from them. But even that's not too hard. And like I say, I have problems with Eagle interface. That's me. That's not, Eagle's a good program too. I find KiCad easier to use.
Yeah, you can find footprints for parts on that you order from Mouser. But one thing I've noticed about Mouser, the footprints they have available are just terrible.
Yeah.
I mean, they're either not labeled, or they're not marked correctly, or they don't have a good 3D model with them.
Yeah.
Just terrible.
Well, another possible source of those, John, is RS Spark's electrical program that's like design mechanical, but they have an electrical program. And so it's what they do is they try to, you can use their library of RC with all their vendors, and all their vendors supply footprints. So you might be able to find stuff in that. I've used gears and stuff from them.
So if you could send me an shoot me an email with how to find that.
Okay. But I've never used their program. I love the SignSpark mechanical, so I mean I might like it too. But I got started on KiCad and many generations.
Back I will say to Harold, one advantage of having your boards manufactured by a third party instead of etching your own boards is you can keep the boards really small.
Oh yeah, and they're gonna drill the through holes for you and do all that kind of stuff. Where I've got some bits to do that around here, but me and my big 8-hand sausage fingers and really tiny bits don't last too long someday. So
yeah, that's true. If you don't have some sort of drill press or a Dremel drill press or something, it's gonna be tough to drill.
I got some of that laying around here. It just I need to.
The program I used to do that two-sided board was DipTrace. That's another free one.
Yeah.
And Osh Park, like a lot of those manufacturers, they'll charge you by the square inch. So if you can get a board under a square inch, it's really, really cheap.
Mm-hmm.
John, who are you using to do the board? What's the name of it?
Oshpark, OSHPARK. So www.oshpark.com will send you right to it.
I use PCB Way quite a bit. They're pretty damn cheap too.
Yeah, but they're shipping from China, so it takes you a lot longer to get them.
No, it's about 10 days, I guess. I don't know how long the other place takes, but it's not.
Yeah, I'm not taking since I do a bunch of streaming and I've got some YouTube channels that have some 3D printers or something. About once a year, the PCB Way people run through here and go, hey, we'll sponsor you if you'll do something. And I've never inquired as to what the something was and how much they would sponsor. And it's posted on my YouTube channel, which I don't do a lot on, so I haven't really tried to take advantage. I think maybe next time I get one of those emails, I'll say, sure. What do I need to do to get some, I don't know, swag or whatever? See if I can sell my soul to the PCB way devil or something.
Well, the only thing about them is when you upload your files and then you say, okay, add to cart, and okay, let me check out. They actually do a design check before they'll let you pay for it.
Oh, that's cool.
You have to wait. Sometimes it's 20 minutes, sometimes it's a couple hours. And then you go back and they'll send you an email. Okay, you can pay now. And, they may adjust the price depending on, what was in the Gerbers or whatever, but
complexity level and that kind of thing.
yeah, but
Yeah,
their stencils are only like $15. So it's really easy to get, a board made and then have a stencil made, which is the way I always do it.
Yeah, so the surface
much
mount
easier.
stuff works, right? Yeah.
well, yeah, PCB Way, I've used them once, and they offer a lot more services than Oshpark does, and a lot more features on their boards.
Yeah, you can get a lot more, different finishes, different platings, different, colors, and a lot of it has to do with what the minimum hole size, the minimum trace width, and all that is. And I think they're 6/6. So, I don't know if anybody's doing something that small, which that's 6 mils by 6 mil trace minimum and 6 mil spacing minimums, which is pretty tight.
And they can assemble, PCB Way can assemble boards for you, but Oshpark can't.
Yeah, I've never used them, for their assembly stuff.
Well, assembly is really expensive.
Is it?
Yeah, because they're going to want they want to get probably a pick and place part thing going on, and it probably takes a good amount of setup to make that happen and do that.
Oh yeah, I'm sure they have a lot of infrastructure to support that, which is why it's so expensive.
Yeah.
Well, thanks a lot.
Yeah, I was gonna say that's
that
more of a
info.
volume production thing. So if you don't have the volume, you're
But I'll tell you, Michael, I want to get into some of that too. I've got a microscope over here and a bunch of training kits to mess around with the SMDs kind of thing. And because that just, I don't know, for some reason that all just scares the hell out of me. Give me a through hole thing, and I'm ready to go. I haven't made it a high enough priority to get over my not fear factor necessarily, do I really want to do this factor? When I got all this other stuff to do.
Harold, I was like you when going from through hole to SMD. It took me a while before I was brave enough to try it, and now
I gotta admit, there's a little bravery you need, because I've got these things. They're only like $1.50 or $3 little kits and setups. But I'm like, man, do I really want to go through all that rejection about you like, oh, you screwed it all up. Okay, give me another one. That kind of stuff. I got to power up for some of that sometime. I don't mind failing, but I'm not ready to fail in that matter.
The board manufacturers also charge you more depending on how many holes they have to drill on the board. So if you go with surface mount, then it also reduces the cost of your board.
Right. If you're doing transfer, I would recommend. Sometimes you can't get away from a surface mounted part. But if surface mounted parts come from itsy bitsy to pretty big. And, the cost to you is less than a penny a part. When you have to buy resistors or capacitors, you buy the big ones. You don't buy the little itsy bitsy ones. And because those little ones, you really got to know what you're doing. If we ever get to another opportunity where
this is one of the boards
starts putting out stuff, so that's like when you're buying the parts. You want to grab if we have step parts that are big, with more spacing between the leads, if it's available. Some, they're from a manufacturing point of view, it's expensive to make leads that are big.
Yeah, this is one of the boards that I had PCB make, but I did the assembly myself. It was for our work on with Murray. I've never been able to get it to work. And I think the problem is that RP2040 chip, the pins have such a fine pitch. I just could not successfully get the thing assembled.
Well, also, John, I don't know if you were doing it, but this might be part of it. Do you know that the RP2040 has the ground pin is on the back side?
Yeah. No,
you knew that. Okay. I want to say that would definitely doom you if you never got that fixed. Oh, here it is. Mauser used to give us these little things.
Rulers, yeah.
Yeah, and if you look at, so like here it talks about the different sizes of resistors. I don't know if you really get this, but so, you got this size, not too bad. And then they got this size over here, and you forget it, I mean, you sneeze and you got them all over everywhere. So those are not the ones you want to buy.
You mean the grain of sand ones?
Yeah, I mean, and they all cost the same. So you might as well get the big ones when you buy them from Mauser,
Yeah, there's a thing.
I mean,
with,
and like John says, board size is important. But what I found is the pin layouts, since I like to use the servo type pin layouts with ground power and signal, they're so much bigger than the rest of the stuff that component size is usually doesn't really matter. They're not driving the size. The pins are driving the size. But that's just because that's the way I like to lay things out. But anyway, that's something to think about.
Yeah, I know if you don't get the amount of solder paste like the same on two sides of like a component, there's a thing called tombstoning. It'll actually flip it up on one end like it's it was a grave marker or something.
Yeah.
So
well, I think that's what I guess, John, that would be my question. Scott said that he could buy a stencil for $15. Could you buy from Oshpark? Can you buy a stencil?
They don't do stencils. Oshpark doesn't do stencils. That's one of
that could be depending on the project. That could be a problem.
Now, well, this board is the only board I've ever done a stencil with.
So you're talking about a solder paste stencil.
Yeah,
right?
you just squeeze it on.
But
it's kind of wasteful of paste. But
I think one of the reasons this didn't work is the pitch on the RP2040 chip is so fine that when you try to put paste on with a stencil, you can't get, it just doesn't go through those tiny little holes correctly. I'm just doing something wrong, or it's just a real challenge to get that chip soldered. But all my other boards have been done. I've hand soldered all my surface mount boards except for this.
Well, there's a trick, and one trick that I've heard of, and I have used it, but I got to admit it's harder than it sounds. Okay, is that you just literally lightly blob up all of the leads along one side, and then you put solder wick over the top of it, and then come back over it, and it'll pull off all the stuff that's not where there's exposed copper. It works kinda. I mean, that's the way techs do it, but for when they're repairing a board. But you get there's a lot. You got to be a pretty good solderer to make that sort of stuff work. But you can do it, especially if the pins will give you some sort of hope. You know.
And I think I may have mentioned it before, but for this board, I've built one of those. I don't know if you've ever seen it, easy make ovens, where you basically you take a toaster oven and a little board.
Temperature
high,
profile controller.
Yeah, it's a little controller with a display on it.
Yep.
And you basically use it to turn toaster on and off, and you basically got a solder oven.
Yeah, James LaCroix did one of those. I think you did one too, didn't you, Doug?
No, I have a dedicated oven, but it's for I use it for what do you call it? Powder
Toasting
coating.
grit?
Powder coating. Powder coating.
Oh, powder coating.
Yeah, Bald Engineer, cat named James as well from Element 14, got a Twitch channel. He redid his just I don't know, a year or so ago. He's got some GitHub stuff out there to take one of these, convection ovens here and put some better control on it and get a screen on it, that kind of stuff. And there's a couple other folks out there that did something kind of cool, and I'm like, wife, what are we doing with that convection oven on the kitchen? And she goes, well, I don't really like it, but it does work when other things don't. So when we decided to get rid of that, I will put that in the project to be done pile of things.
A lot of people now are using hot plates.
Yeah, I've seen hot plates, and I've also seen them. The other thing I might do around here, that iron plate is pretty high, and if you take some of the guts and mount it on something and control that, you can do your temperature control with that thing. I've seen a bunch of folks examples of doing that on YouTube, because it gives you a pretty decent size of things, and we're not making boards the sizes of PC cases. They're all going to be relatively small. They would probably fit on top of an old iron that, well, obviously I can't do it with a Rowena because she'll get real mad at me, just like her Fisker scissors. I mean, I'll be in all kinds of trouble then. But the throwdown one that comes around here might get reused for that.
Oh, I think one of the things that I would say is whatever you do, don't use your wife's iron for toner transfer, because if irons a lot of times have Teflon on the bottom, and using it for toner transfer is going to screw that up. So don't go down to Goodwill and buy one for $7, and you'll be a lot better off.
Yeah. And once you've used your toaster oven for a solder reflow oven, don't go back and use it for toast.
Nothing else. Yeah.
Really? Who doesn't need a little lead in their system on occasion? I'm just saying.
God knows what else. Yeah.
God knows what else, exactly.
Yeah. Not good for raisin bread toasting anymore.
The next wave will be the air fryer reflow ovens. So.
Yeah.
There you go.
Air fryer. You joke, but if those air fryer ovens do anywhere near, like I've got this heat gun I've had for 20 years, I turn that thing off and close up all the vents to make it hot. What do you want me to destroy? It may take a little bit, but it will melt right through it and burn right through almost anything.
I'm sure we've started to dabble with. They would do a lovely job.
I do have a hot air rework station over here with a little bit of air gun, and I use it primarily for shrinking, the shrink tube. It does a really awesome job about that, and I feel much more comfortable doing that than pulling out the lighter or trying to be steady with the tip of the iron, of the soldering iron, because I'm always bumping into it or something. It does a really nice job of that, and because I can contain the airflow and that kind of stuff.
And Harold, don't try hand soldered surface mount unless you got a real steady hand.
Yeah, I've been noticing that. I've been watching people, and like I said, I've got a USB microscope with the screen and things. We talked about this, and I've got my stuff to go straight down, and I took your guys' advice on that, and it looks like because these guys seem to just slop things on there. Like they'll get up and they'll put like I don't know a gallon of flux on it, then they'll do some soldering on it to go over everything, and the flux makes it stick to the metal pads it's supposed to be, and they'll put the part on the top, and then start going over a little bit, and they're done. They make it look way too easy for what they're doing, and I'm like, yeah, I know that's probably not going to work that way for me. I got a sneaky suspicion. Not to be negative, but that's probably somebody that's does it every day, and that kind of stuff.
Yeah. But like I say, if you're using those push wire, where you push the wire into a plastic block that has, it's a proto board, you know what I'm talking about. If you're doing that, unless it's really simple, or you're trying to prove something that you're not really sure about, like maybe you're biasing some sort of circuit and you want to make sure it truly is biased, right? I recommend just any project of complexities, you just draw it out on KiCad and get the circuit, and then once you have the circuit, making the PC board is like pretty simple once you have the right layout, the right footprints, and just
I'll look into that.
Just make you a quick one, and then it's a good way, that way you never have to worry about, well, did this not work because I didn't wire it right?
Yeah.
You know what I mean? Well, you still have to worry about that, but it's a lot less worry about it.
You got to deal with the chemicals, though, right? I mean, so I've started to help clean up my parents' house, and I found some photoresist stuff in the basement from when my dad and I made something in the 70s.
Well, yeah, but
I did that before. I got the copper clad from Radio Shack. I got the pen where I drew all the circuit. And
yeah,
I've done all that before, and that was it turned out well. It kind of worked, and it was kind of cool to say, "Hey, look, I made my own circuit board. Does it work?" Well, it's like
With the toner transfer, you take your circuit from KiCad, and you just go get a laser print. If you have a laser printer at home, which some people do, you just print out a sheet, take your iron, heat it up, push it down, and when you're finished, you you wash, water, peels right off. You got your pattern there on the thing, and if you use it can be harder. I used to like to use photo paper, which is a mixed blessing, because if you use cheap photo paper, which works really well, you get the coating is kaolin, like they used to use in Playboy magazine. You know how that slick paper feel? It's kaolin, and that gets transferred with the heat, and it can be a booger to get off. All right, but that's about the only problem with that process. And there are papers that you can get from, well, I don't know if they're still open. Is there Staples? Are they open or are they dead? Anyway, places like that, there's what they would used to call their premium paper, which was slick, but not as slick as photo paper. And that worked real well. That was a good transfer paper. Or you can buy special, if you really want to, you can buy special transfer paper.
Oh, okay.
That's probably the easiest way.
You can only guess why they were coating the pages of Playboy magazine, right?
Yeah. We didn't need. I'm usually.
Well, I could have said Life or any of the
Life
other
magazine.
Life
Time
magazine.
magazine.
Yeah.
National Geographic.
I was
any of
using
the- any of
design
the old-
circuits.
I thought I heard. So
Yeah, boys life. Boys life. There you go.
Oh, by the way, speaking of ovens, there's a company out there, Vior. They have a oven ready to go that will do boards up to about 7 by 9 inches for $160 delivered.
Mhm. Well, yeah, but that's kind of like, is it worth your time to build it or not? And the answer, if it's worth your time to build it, the answer is almost always no. You you can always buy it better than you can build, but
Yep.
it depends on whether or not you want to go through that. Because you can go to, like I say, you can buy an iron for $7 to $9 at Goodwill, and you can buy a toaster oven, some really nice toaster oven, better than the one I have at home. You can buy for like $22 or so. So. And they always have toaster ovens, and they always have irons for some reason.
I mean, like, I bet I could go down to Ollie's. I don't know if you guys have pictured in one of those stores that's been around the Metroplex.
Yeah.
But they're the one, good stuff, cheap. I bet they've got stuff that's fairly cheap that you can pick up, and you won't care that, it's brand new and you're ripping it apart to do something with.
Yeah.
Is my thought on that.
It's getting late, folks. I'm gonna bail.
Yep, I'm going to agree with him.
Not the
Yeah, I'm
same
getting
here.
tired myself.
All right. So guys, good to see you all.
Welcome back.